Hello everyone, good morning. Today inshallah we will continue on the topic that we started previously in the previous two lectures. I will start with the operations. We already did go through this. What's a matrix? The various types of matrices. What's the condition for addition and subtraction? What's the condition for two matrices to be equal to each other? How to do multiplication in matrices, if you remember. This is really very important. And I believe the last thing that we spoke about in the previous lecture was how to go through a system of linear equation. This is linear algebra, course code SVE 1311, and I'm Dr. Omar Muhammad Salah. I'm not going to be with you. The rest of the course notes, references, you will find them on Moodle. Also, you will find a couple of threads from Lisbon talking about these topics with details. So please do go through them, okay? And also you will have all the course materials till Moodle works perfectly and till the accounts are ready. I will send you the slides that I have through WhatsApp, so you should be in a very good situation. Okay, I believe in the previous lecture we already spoke about this. We talk about how we can find an equation in several variables, like this one. You have an equation with xn number of variables, unknowns. Of course, a1, a2, a3, up to am, those are the coefficients of these variables, and then it's equal to b. For simplification, if I talk about an equation with just only three unknowns, the shape is going to be simply like this. 3x1 plus 2 of an x2 plus, let's say, 4 of an x3, which equals to 6 or something. This is an example of an equation which have several types of variables from x1 up to x3. As you can see, this class of equations, you can't solve them and identify the values of x1, x2, x3 just from one equation as we spoke in the previous lecture. I have to have a system of equations already with me to be able to solve this type of equations. To have a consistent system of equations, the number of equations should equal to the number of unknowns. So if I have an equation with three variables, at least I will need another two equations separate, not dependent on this equation. So three new equations. Let's say 2x1 plus x2 plus x3 equal to 4, somewhere, whatever, negative x1 minus x2 plus 3 over x3 equal to 5. These equations in the real life situations would come from the prices, the quantity, the amount, the quantity supply. For example, for more than one competing company, you can interpret that into something like this. It has applications almost in every field, in general in STM, science, technology, engineering, mathematics, in every field, whatever you think of. So the problem is how to solve such a class of equations. Before going through this, I feel that I need to explain it to you on the simplest system that exists. And also, I want you to understand the differences between a singular or a unique solution, an infinitely many number of solution, and a no solution. Although this simplification is not exist in the main book, but I insist on you or for you to understand it. It will make a huge difference. A simpler system than this one, which is three unknowns in three variables, it's gonna be, for example, if you have x1 minus x2, let's say, equal to 4. Also can work with 2x1 plus x2 equal to 6, which represent in geometry two straight lines. It's an equation of a straight line. I'm sure in the foundation you know how to represent an equation of a straight line. An equation of a straight line in the nicest form ever, y equal to x plus 6, for example, which is an equation for a straight line. In a straight line, if you like to represent it or to graph it, you will need at least how many points? Just only 2 points on it. So simply we can insert x equal to 0 and we will find y equal to 6. That's a point. The other point, let's plot x equal to 1, for example, any numbers, and it will lead to y equal to 8. So you will have 2 points. So if I want to represent this straight line, which is an equation in how many variables? Look, it's an equation in how many variables? So any equation with 2 variables, it's actually a straight line. Okay? It will make no difference to call the variables x1, x2 or y and x. It will make no difference. Okay, if I want to graph this line, I'm going to just sketch anything. Okay, it's like that. This is a straight line, which is a representation of any of these 2 equations. So let's say this is equation number 1, and this is equation number 2. If I want to represent it, this is going to be, let's say, this is equation number 1, and this is not correct. This is not the shape, but it's a straight line. If I want to graph the other equation, and if they are completely different than each other, the other equation will be like this. This is equation number 2. If you remark, these 2 straight lines will intersect at a certain point. Intersection means you will have a value for x1 and a value for x2. And this values for this point, which can be written like x1 and x2, actually it makes these 2 equations correct at the same time. This is what we call a unique solution for a system of equation. So if I have a system of equation, the simplest one is 2 equations in 2 unknowns, which can be represented simply by a straight line. A unique solution, it means these 2 equations will intersect at just only 1 point. This is what's called a unique solution. Okay, there is another situation you can face. If these 2 equations, the slopes are the same, so if I start to draw these 2 equations together, this is equation number 1, and that's equation number 2. Actually, they are parallel to each other. In this way, is there a possibility that they will intersect? Actually, they are parallel to each other, so they will never intersect. In such a case, in a case like this, we will have no solution. There is no intersection point, so there is no solution for these 2 equations. In the other case, if I have 2 equations and they are identical with each other, so simply I will give you, let's say, x1 plus x2 equal to 2, then 2x1 plus 2x2 plus 4 equal to 4. Look at these 2 equations in specific. They are the same. Actually, I made a joke with you. I've given you one of these equations, then I've multiplied, and you need 2 equations here, right? Okay, this is one of them. I will multiply it in a certain constant, in a scalar value or something. So actually, it is just only 1 equation. No new information. It's like, Galal, please go bring us 1 cup of a coffee and 1 cup of a tea from TBS. He went and came. How much did you pay? He told us, I paid 100. So, okay, I'm sorry, Galal. Please do bring us 2 cups of coffee plus 2 cups of tea. He went and came. How much did the cost? We will pay it for you. He said it's a 500 issue. So there is a problem. Okay? Once he said that, there is something wrong between these 2 equations. This is the equation of they are parallel to each other, they are not going to intersect. But if you went downstairs and he came, the value, the bill value or the receipt for the first order was 100, the second we double it, so we are expecting to have 200, to pay just only 200. So actually this is the case if they are inclined to each other, and in this case, what are the points of intersection between these 2 lines? They are coinciding in each other. So this is the case of infinite number of solutions. This is the case of no solution. And that's the case of a unique solution on the geometric meaning for the simplest system ever exists. A system of 2 equations in 2 unknowns. Unfortunately, when you speak about three unknowns, you will go from 2-dimension into 3-die, x, y, and z. So the interpretation for these equations is going to be plans. So it's going to be harder in geometry to understand them. Like, if we are talking about another equation or another system of equation which contain 4 unknowns in 4 variables, 5 unknowns in 5 variables, 6 unknown, blah, 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 till you reach n unknowns in m equations, for example. Something like this is going to be enormous. So we are going to solve it, but we can't find the geometric interpretation, or it's not going to be easy on us. So the simplest way to deal with it is to move it to matrices. From my point of view, this is why we invented matrices, with all the properties that's involved in matrices. Okay, this is all an introduction. I just want you now to know what I really wanted to be in your mind, that how many type of solutions are going to face 3 of them. What they are: unique solution, and no solution, and infinite number of solutions. Okay, forget all of this about the straight lines or something. I'm not going to go through it, but now you know. And for the Python programming part, he starts to show you the interpretation of 3 unknowns in 3 variables, an array or something, and giving you the vectors and the cases related to these vectors. This is mainly the main idea of playing with Python programming in this one. Okay. Okay. For this system of equations, I can simply, زي ما احنا شفنا كلام امبارح, adjusted to be on this form. I will take all the coefficient matrix, all the numbers, I will put them in the coefficient plot, times the unknowns, which are the X matrix, and it's gonna equal to the results. This is the system that we are going to deal with. Okay, one of the famous methods to go through this, it's what's called an augmented matrix. I feel also it's better to explain it on equations in front of you with numbers. Let's say, get back to 3x1 plus x2 minus x3 equal 4. 2x1 plus x3 equal to 6. x2 minus x1 plus x3 equal to 10. I want to put this system of equations on a matrix form. Any help? Any suggestions? The first is the coefficient matrix. But before we start, please try to be sure that all the equations are well arranged. The first are the values of x1, the second column are the values of x2, and the third one is the values of x3. If there is a change in these variables or in these positions, please try to adjust it. And remember the sign conversion. So I will start. The first number is 3, which is going to be 3. The value for x2 is positive 1. The value for x3 is negative 1. Okay, I'm going to, this is just only the coefficients of the first matrix. Please be careful. For that of the second equation, the value of the coefficient of x1 is going to be 2. Do you have x2 in this equation? 0. Yes, you have. Yes, you have. But unfortunately, the coefficient is 0. And we don't write 0 times something. So actually, there is 0 over x2. x3, it is positive 1. Please be careful with the signs. I'm going to the third equation now. And also, before you work, you should insist that it is well arranged. So it should start with x1. Okay?
Negative 1.
Yes, exactly right. So it's negative 1, then positive 1, then positive 1. I will multiply this coefficient equation times the unknowns, which are x1 in order, x2, then x3. And all of them equal to the result equation. Also, remark, For the system of equations, you should have all the variables on the left-hand side. It's always like this. It's better to be like this. And all the numbers to the right. Remark, if I put 6 on the other side, you will have to move it and change the sign. I'm not gonna talk with you about this. It's your own issue. Now you know. Okay, I will start to write them down. So it's gonna be a 4, then a 6, then a 10. See how everything is coming together. First of all, these matrices suitable for multiplication. Yes? Yes, it could be multiplied. It's correct. This matrix is, I need dimensions please.
3 by
3 by 3. And that one is
1.
3
3 by 1.
times 1. And the result will be
3 by 1.
3 by 1. It made complete sense. Great. This is 3, number of columns equal the number of rows of the second, so it's possible to multiply them. C1, so we try to multiply. I will multiply the first row by the column. So it's going to give you 3x1 plus x2 minus x3. So it's actually the first equation, which is going to equal to 4. So simply, a system of equation can be adjusted more than beautiful in a matrix form. What we want to say now is to introduce what's called an augmented matrix. مصفوفة كبيرة, مصفوفة مجمعة, an augmented matrix. The augmented matrix, always like this. Don't you ever forget it. We are going to play a lot with it. 3, 2, negative 1, 1, 0, and 1, negative 1, positive 1, positive 1. I myself would prefer if you make this line like this, a dash line, and then I will write the results. So it's 4, 6, and 10. All engineers, they can look behind the scene. Well, actually, I'm imagining that all this part is disappearing. Can you see this part? And instead of having all of this, I will just simply change the thing by this dash line. This is the augmented matrix. So it's simply the coefficient matrix, then the last column is the result. This is called the augmented matrix. And this is a very famous matrix. It summed up everything. A system of equation into a matrix form, then into a compact form, containing 2 matrices. Don't you ever forget, 2 matrices. One of them is the coefficient matrix, and the other one is the result matrix. Okay? Any questions? Galel?
Yes, we don't do reduced echelon form.
We will.
We will now.
We will, but we will do it on what? The augmented matrix. Okay? Okay, perfect. So, till the time being, I think everything in order and it's very easy. Okay. This is what we said. This is what we did go through. This is the generalized form of a system of equation, and this is the generalized form of the augmented matrix. We are going to the echelon form and how to go through it. The echelon form, if you read it, it will tell you that all 0 rows are below non-zero rows. Zeros are going to accumulate in a lower triangular matrix. So I'm going to try to make an equivalent matrix to this one, but with a lot number of zeros, or plenty of zeros. I will form these zeros to be on the echelon form. The first non-zero entry of non-zero row in the column to the right of the first entry, and we call it a pivot, as you will see soon. How to transform an augmented matrix to a system of linear equation into a matrix in echelon form, the Gauss elimination method, and we will spend some time here in this slide. Okay, guys. What are the main row operations or the elementary operations in matrices? The most famous one are the Gaussian row operations. There are 3 of them. All of them were invented from the good understanding of a system of equation. Remark, multiplying any equation by a constant number, and it is a balanced one, is it going to change anything? This monkey, Abdul Rahman, is it going to change anything? So instead of dealing with 3x1, x2 minus x3 equal 4, I will deal with, I like it this way, x1 plus x2 over 3 minus x3 over 3 equal 4 over 3. Is it the same? Why does it say Abdul Rahman? Because I've divided all the elements on 3. Or maybe I multiplied all the elements by 1 over 3. So multiplying one row with a constant number, it's gonna give an equivalent row and it will be almost the same. Okay. If I like for this system of equation to replace the same thing giving you the second before the first, is it gonna make a difference? I'm not gonna write it like this. I'm gonna write it 2x1 plus x3 equals 6. Then I will give you 3x1 plus x2 minus x3 equals 4. Then the last one will remain the same. Is it going to make a difference? From here, replacing rows in an augmented form, it's not going to make a difference. It's an equivalent form. Are you reading me, Galal? So multiplying a complete row, which means multiplying a complete equation in a certain number, it's not going to change it. Yes? Okay. Switching rows, it's like switching equations, so it's not going to make a difference. Another one. This equation is well balanced. So the left-hand side equal to the right-hand side. The other one or the third one is exactly the same. The left-hand side is exactly equal to the right-hand side. Is it going to make a difference if I took this equation into my mind and I add it to this one? And now, if I did that, a new equation will come, which is going to be simply 16 equal to 2 over x3, then it's going to be plus 2 over x1, then, 1x1, okay, and I will have x2. I did nothing, I've just added this equation into that one. So 6 plus 10 is coming to 16. And then x3 plus x3 is 2x3. 2x1 minus x1, you will end up having just only 1x1. And you have x2. Do you think this equation is balanced? Yes. You have taken 2 scales which are equal to each other, and you carried them and you put them on another 2 scales and they are equal to each other. The result, you will have these 2 sides equal to each other. These are the 3 row operations. Anyone can tell me once again, what are the 3 row operations? Switching rows. Multiplying one row by a scalar. Okay. Multiplying another row in my mind and then add it to another row, it will make no difference. They will be the same. If you remark what I did on these equations, I'm gonna do on this augmented matrix. Look to the first row. The first row is exactly the first equation. Look to the second row, which is exactly the second equation. Answer. This is mainly from where all the 3 operations that you can see is changing 2 rows and it's not gonna make a difference in the augmented matrix. Multiplication of a row by a non-zero scalar make no difference. You have an equivalent row. Addition to a row to another or multiplied by a scalar, it's not going to make a difference or an equivalent row for the main one. Okay, he's saying to you, if we have 2 matrices and M and M are said to be row equivalent, if you did what we are talking about right now. Switching rows, multiplying some rows in certain number, and stuff like that. If there exists a finite sequence of elementary operations, endless operations I can use. Multiplying, replacing, multiplying one row in -1 or multiplied to 1000 and added to the other. So actually it's an endless operation. Okay, overrule the transform M into M. In that case, we write M is equivalent to M. They are balanced, equations are okay, and everything is fine. Systems with row equivalent augmented matrices are equivalent. System بقى كله على بعضه. You have 10 equations and 10 unknowns, 3 equations, 3 unknowns, 2 equations, 2 unknowns. It's exactly the same. All what's going to make a difference, the system is bigger, the system is smaller. For bigger systems, you can use computer softwares that's going to handle all of this in a manner of parts of a second, okay? A matrix in architectural form, the first non-zero entry of each non-zero row is called a pivot. I will make you learn how to do this using the row operations there. Should be perfect. This is actually the outcome that I'm hoping that I'm going to gain today with the understanding of the 3 cases that we are subject to: a unique solution, one when it's going to happen, an infinite number of solutions when it's going to happen, no solutions, and the difference between them. This is very, very important. I was hoping that everyone is attending today, but anyhow, the video is recorded, so anyone can share it, and we will go through it next time, inshallah. But remember that next week, we will see each other just only on Wednesdays and on Thursdays. Okay? If you have anything or any issue, please don't hesitate to stop by our office. I will put the office hours for you if you need anything or any help at any time, and also we are connected through the WhatsApp and emails. A matrix is to be a reduced echelon form if it is a matrix in echelon form and it satisfies the following: all pivots are 1, each pivot is the only non-zero entry in its column. This is called Gauss-Jordan system, and we will be very good in it, inshallah. Okay, each one is equivalent because we are done from all of this. Okay, I wanna talk about this slide. Just give me 1 second. I'll lift the rope. I'm afraid that you will nearly fly. كده في اتش كلها عرفت ان انا عايزه كان فظيع.
يا باشا الف سلامه. السلام عليكم.
اوكي يا شباب، ارجع بقى معايا. دي انا عايزها تحفر في دماغك. خلاص it's in. It will never go out. A system of equations simply can be written as A times X equal VD. Okay, there is 2 options for you: a consistent system and an inconsistent system. Consistent system, it means you have a unique solution or infinite number of solutions. Inconsistent system, it means there will be no solution. These 2 equations are not right. There is something not correct embedded in these 2 equations. It's exactly like the situation that we were telling Galal that he will bring 1 cup of coffee, 1 cup of tea equal 100 EGB, 2 cups of coffee, 2 cups of tea, and the result is 500. How is it going to come up to 500? There is something wrong, either in the first balance or in the second equation. Okay, this is what's happening in inconsistent system of equation. Okay, for the consistent system, as I told you, you have consistent, independent number of equations, which is going to result to a unique solution. Actually, between us, here you will hit an identity matrix. You will see that now. From this, in order to get a unique solution, you will be able, in echelon form, to get a unique matrix. And then it will give you just only a unique solution. In such a case, the system is consistent, but some, not all of them, maybe all of them, they depend on each other. So you will have infinite number of solutions. Once more, I can say it once more. To have a unique solution, the number of unknowns must equal to the number of the independent equations. To have infinite number of solutions, the number of unknowns is less than the number of the independent equations. كلام واضح؟ بالعربي. عشان يهمني انك فاهم كويس كده. عشان تجيب حل وحيد لازم عدد المعادلات يساوي عدد المجاهيل، والمعادلات مختلفة عن بعضها. دي مش معتمدين على بعض. عشان تقدر تجيب dependent system او يبقى معاك infinite number of solutions، يعني عدد لا نهائي من الحلول، لازم عدد المجاهيل يكون اكبر من عدد المعادلات اللي انا مديها لك المختلفين عن بعض. اوكي؟ وده هيبان دلوقتي في حاجه اسمها الرانك. We will go through it also by rank. If you see the next slide, so any questions about this one? Okay, this should be very, very clear. For the second one, we will define what's called the rank of a matrix. What's a rank of a matrix? بالعربي رتبة المصفوفة. The rank of a matrix. What's a rank of a matrix? The rank of a matrix is the number of pivot positions of any echelon form matrix, row equivalent to m. أنا مش بحبها كده. It is the number of non-zero rows that exist in a matrix. The number of non-zero rows that exist once you are trying to get the echelon form. يعني أنا عندي matrix موجودة numbers زي النمبرز دي. I will try to play with it, with the row operations or the matrix operations that we saw previously, seeking to make this matrix to be a unit matrix. If you hit that this matrix, which is 3 by 3, a unit matrix 3 by 3, you will have a unique solution. If you ended up having a 2 by 2 unit matrix, not 3 by 3 unit matrix, then you have infinite number of solutions. One of the rows should be zeros from the beginning to the end of it. This is an infinite number of solutions. The third case will happen once you have a zero row in the coefficient matrix, but not a zero value in the result. So actually it's like 0 equal 10 or something. So there is no equation. الرتبة with respect to the rank. If I have these 3 rows, not all zeros, then once we are seeking to get it on the echelon form, so none of them is equal to 0, so the rank is going to be 3. And the number of unknowns is 3. So once the number of unknowns equal the rank of a matrix, you will have a unique solution. Okay, I'm trying to do the echelon form, but unfortunately, I found that this equation this matrix, just containing 2 rows with just only numbers. And there is a complete row in the coefficient matrix which equal to 0. In such a case, this is the rank equal to 2. While you have how many variables? 3 of them. So the rank is the number of variables. So in such a case, you are in between 2 things. Either infinite number of solutions or no solution. When it's going to be no solution, if the rank of the coefficient matrix is 2, and the rank of the augmented matrix is not equal to 2. This is not 0. So it's 0 below, it's 0 to the left of the blue line, and it's not equal to 0 to the right. Such a case will make the rank of the coefficient matrix is 2, while the rank of the augmented matrix is 3. In such a case, there is no solution. But if the rank of the coefficient matrix equal the rank of the augmented matrix, but less than the number of variables, you will have infinite number of solutions. This is actually written in here. See, if the rank of A equal the rank of the augmented matrix, 3, and all of it's 3, so you will have a B solution. If the rank of the coefficient matrix not equal to the rank of the augmented matrix, you will have no solution. And this mainly will happen while you have 0, 3, and this one is not 0. So this is the no solution case. Okay, if the ranks are equal and they equal to the number of unknowns, you will have a unique solution. If the ranks are equal but they are not equal to the number of solutions, the number of variables, then you will have infinite number of solutions. أي مشاكل نفسية؟ أنا عارف إن الجزء ده لازم you will have to repeat it more than once. تعال بقى إيه؟ Any questions? Okay, let's start running.
The unique solutions?
إيه؟
The unique solutions.
Which one? D? I'm not really sure. I don't know. Yes, if we succeeded in making the coefficient matrix equal to unit matrix. But for the first block, I really don't know. I'm not sure.
دكتور
Okay. Yes.
معلش حضرتك معاك شاحن ايفون؟
لا انا نفسي متعذب في ده مش معايا الراس بتاعه. اوكي طيب بصوا يا شباب this is what's called Gauss Jordan. It's a part of my book. It's adjusted with what we are taking, but it's more I see it's what I'm saying is it's going to be more easier if we did go through it to understand the row operation in specific. Okay, once more, row switching, it will make no difference. Okay, row multiplication, if you multiply a row with certain value, it will make no difference. Row addition, multiplying in a row by a certain value and adding to the other row, it will make no difference for you. Or you will have an equivalent form matrix as they said previously. Form steps of solution. First of all, for any system of equation, you will have to form the augmented matrix. This is the augmented matrix that we are talking about. Step number 2, use the basic row operations. Row operations in order to get what? To try to change this equation, this matrix, to be identity matrix. What's nearing to be identity matrix? The I matrix. Okay. Once you reach I matrix for the same dimension, those are the results of your equations. And we will see it and we multiply it and everything. Okay. If the unique matrix could be obtained, the solution is unique. If not, you will have finite system of solution or no solution. Okay, let's go through it. These examples are really very important. I will solve them, the 3 of them, we should solve them together. I will solve the first one in depth, then I will give you papers and I want you to try it by your own, okay? It's really very simple, but you need to focus. الساعة كام دلوقتي؟ 10. Okay, I will give you 10 minutes break, then I will continue, okay? That's it. Thank you very much.